Hello, today we'll be discussing our project titled Formulating an Efficient Real-Time Monitoring and Countermeasure Framework for DDoS Attacks with Python. So this presentation will basically be covering the development and implementation of a robust system designed to defend against DDoS attacks. So to begin with the introductions, our team comprises of four dedicated members, uh, myself, Varshat, Shailender, and Nikita. uh, each of us has have significantly worked on various aspects of this project, from research and development to testing and evaluation. Coming to the next slide. These are basically the table of contents of the presentation, which include introduction to DDoS, background and modification challenges, solution overview, packet analysis with KP, heuristic detection rules, web-based dashboard with Flask, automated response mechanisms, evolution and objectives, importance for next network security, literature survey, system design components, conclusion, and the reference. So DDoS attacks are basically malicious attempts to disrupt the normal traffic of a targeted server, service, or a network by overwhelming it with flood of internet traffic. Basically, these attacks can cause significant financial and also damage to the reputation of various organizations. Traditional defense mechanisms basically fall short in effectively countering these threats, highlighting the need for real-time monitoring and response solutions. So our proposed system leverages Python to offer a proactive and adaptive defense. And the next slide, in the background and modification comes where, so basically the digital revolution has greatly increased connectivity, but also increased numerous security concerns and risks. DDoS attacks are now more common and damaging than ever before, with costs ranging from thousands to millions of dollars, which is very huge. Traditional defense methods are very ineffective against evolving strategies of attacks, so underscoring the necessity for real-time automated defense mechanisms. And the solution overview is it is basically a Python-based framework for real-time monitoring and response to DDoS attacks. It utilizes KPU for packet analysis and Flask for web dashboard. We employ heuristic detection rules and machine learning algorithms to identify threats. Automated response mechanisms such as IP blocking and traffic rerouting are implemented to maintain network availability during an attack. So this is how the solution overview has been designed. And from now, my friend Nikita will take over.
I'm Nikta. I will be continuing from here. The packet analysis with Scapy. Here, Scap is a powerful Python-based tool used for network packet manipulation, which includes capturing and analyzing network packets in real time. Here is a more detailed explanation for that. Here, Scapy allows users to capture live network traffic, which means it can intercept packets as they are being transmitted over the network. Here, in the real-time analysis, it's crucial for understanding the current state of the network and identifying the immediate issues. In this Scapy, users can dissect and examine the details of each packet, including headers, payloads, and metadata. This granular level of analysis provides detailed insights into traffic patterns like source and destination, protocol usage, packet size, and training. Next slide. Here is the detection rules. Here, DDoS attacks typically follow certain patterns that can be used to identify them. These patterns include massive volume of traffic, multiple sources, specific protocol usage. Here, Scapy evaluates multiple attributes of network packets to identify potential DDoS attacks. By evaluating attributes like source IP, packet size, and protocol type, and detecting unusual traffic spikes and repeat access attempts, Scapy provides a robust framework for identifying DDoS attacks. Its real-time packet analysis capabilities ensure quick threat identification and response, while advanced patterns recognize techniques help reduce false positivities and improve overall detection accuracy. Here, this makes CAP an invaluable tool for maintaining network security and mitigating the impact of DDoS attacks. Next slide. While Scapy itself is a powerful tool for packet and manipulation analysis, its Integration with user-friendly interfaces can greatly enhance its usability, especially for network administration who may not be familiar with the command line contribution. Integrity is capable with the user-friendly interface and visualization tools greatly enhances its utility for real-time network monitoring and security management. This interfaces simplify configuration and operation, visualize the traffic data and alerts, and provide tools for managing security responses. Real-time matrices like packets per second and IP address distribution help administration quickly identify abnormalities and threats, ensuring a robust and response network security posture. From here, my friend Varshit will be continuing.
Automated response mechanism. Upon detecting an attack, our system triggers automatic countermeasures. This include IP blocking to reduce incoming traffic attacks and the rate limiting to control request volume from a specific IPs, and this traffic rerouting to distribute load and prevent single point of failure. These measures ensures a rapid response, minimizing the distributions and downtime. Next slide. Evaluation and objectives. We tested our systems on simulated attack scenario to evaluate its efficiency and reliability. We measured detection accuracy, response time, and network stability, and identifying strengths and areas for improvement. Our goal is to enhance network security and service continuity, with the future work focusing on algorithm fine tuning and border application. Next slide. Importance of network security. Traditional defense mechanisms aren't enough to stop today's advanced attacks. We need solutions that can act quickly and in real time. The system we are proposing provides strong, scalable protection. It used an advanced method to analyze data packets, detect threats using patterns, and automatically respond to attack. This approach boosts the overall security of the organization. From now, Shailendra will continue.
So moving on to literature survey. This survey looks at current ways to stop distributed denial of service, that's DDoS attacks. It highlights the need for systems that can monitor and respond to threats in real time. The survey discusses using machine learning to detect attacks and creating secure network designs. It emphasizes the importance of solutions that can adapt and scale as needed. Finally, it points out the areas where more research is needed to improve the DDoS protection. That's the distributed denial of service protection. Moving on to system design components. This framework, this application fights DDoS attacks using several key components. It analyzes network packets in real time with SCAPI, detecting unusual patterns. Heuristic rules based on known attack patterns help identify threats quickly. A web-based dashboard built with Flask provides real-time monitoring and alerts for administrators to have a quick eye on the application or the attacks. Automated responses like blocking malicious IPs and rate limiting when an attack is detected. The system is tested with various attack simulations to ensure its effectiveness. The integrated approach allows for quick detection and response, which in return helps the network services running smoothly during attacks. In simple words, to explain the system design components, the system combats DDoS attacks with real-time monitoring, detection, and response. It uses CAPI for analyzing network packets and a Flask for a web-based dashboard. Heuristic rules plays a major part here by automating the responses like IP blocking and rate limiting or mitigation threats. The web dashboard offers real-time visualization and alerts, helping administrators to monitor and to manage the security. This integrated approach That's this application basically ensures quick and effective action against DDoS attacks, maintaining the availability and reliability of network services. Moving on to conclusion and the future works, the proposed Python-based framework for DDoS attack detection and mitigation using SCAPI and Flask combines real-time packet analysis, heuristic detection rules, a user-friendly dashboard, that's a Python GUI, and automated responses. It achieved high accuracy in detecting attacks like SYN floods, UDP floods, and HTTP GET floods with precision and recall above 90%. The system responds within 2.1 to 2.7 seconds, maintaining network performance during attacks. Case studies confirmed its effectiveness in real-world scenarios. This robust system, the application which we have built, is crucial for network security professionals. These are the references which we have used for the construction and the developing our project. Thank you. That's all about our project.